the receiver an idea that somebody has played around with the message in between when it is being transferred. Right? Encryption above hash message is basically done what you call it as a digital signature. So what happens is it's a two-step process. I encrypt my message using hash algorithm. Hash algorithm generates a hash message or a message digest. I encrypt this message digest and send it across the network. So if that's what I wanted to say, if suppose in between some intruder happens to hack my message and he or she changes something in between, then in that case, what happens? The message digest will get changed. So what message digest I am sending to the receiver will be different, and what the message digest will be generated by this cryptography will be different, so that a person comes to know that the message has been changed. So a hash function is a mathematical algorithm which I was talking about, which gives unique fixed string, as I said, to any given message. Hash value is unique for each message. That's very clearly remember. Even if you add a one full stop to it, the message hash value will change, or the message digest will change. If you write something in which was written in small letters, and if you make it to a capital letter, it will change. It is very, very sensitive. Digital signature encrypts, that is, it tries to code it, the hash of the message, and not the message itself. It will, what I am trying to say is that I have written a message, then I have generated a key which is called as a message or a message digest or a hash using a hash algorithm. Now this message digest will try to give the receiver an idea that the message has been originally intact, because when he will use this, he will find that the message remains the same. Now, digital signature encrypts the hash of the message and not the message. This is the reason we were talking that the confidentiality is not ensured by digital signature, because if you are encrypting a message, then you can ensure that the digital signature will ensure the confidentiality. No, digital signature does not ensure the confidentiality of the matter. It says that digital signature only ensures that whatever message has been sent across the network has not been tampered, altered, manipulated by any person in between the transit. However, there is no guarantee that whosoever in between the system has or can see the message. So in a way, if you talk about digital signature, the only feature which it lacks is that it does not provide you confidentiality or the privacy of the data. Now, when you are talking about encryption, so you use in technical terms in cryptography, the two keys are used, private key and the public key, right? So private key of the sender, suppose I am the sender, I'll use the private key for encrypting the hash of the message, because I am not encrypting the message. I am encrypting the message digest, which I have generated using hash algorithm for my message. That hash algorithm or that hash value or the message digest will be encrypted using my personal private key, and this will be sent across the network. Non-repudiation, this was the question asked, that which of the following things digital signature does not provide, and out of that, all the integrity was there, confidentiality was there, non-repudiation was there, everything was there. So you have to select the answer that it does not provide any confidentiality when we are using the digital signature for transferring the message across the network. Now, non-repudiation, as I have mentioned earlier, it is the strongest evidence that a specific transaction has occurred and no one can deny about the transaction or the action. That is, it is clearly that you are responsible when you are sending a message using digital signature. And this is the reason that now these days, chartered accountants are signing most of the documents using UDIN and the digital signature. Just for your explanation, I have used the two words encryption and decryption, so I'm explaining it to you. Public key cryptography is a method of encrypting or signing data with two different keys. One is the public key and the other is the private key. As I mentioned that when I was encrypting the message, my message, I use my private key. And this was one method. Public key is available to anyone, and data encrypted with public key can only be decrypted with the private key. I can encrypt with private key and ensure that the public key is available to every person who wants to decrypt it, right? And at the same time, if I'm encrypting my data using public key, then the receiver need to have the private key of mine to decrypt the data. So encryption is coding, decryption is decoding. Now, when you are talking about cryptography, it is essential, I mean, that we must understand what is asymmetric encryption and what is symmetric encryption. Name itself says asymmetric encryption means that you are using two types of keys. The receiver and the sender both are using different set of keys. So private and public keys are used for encryption and decryption. We have already spoken about. Message encrypted using private key can be decrypted only using public key. And because we are using two types of key, public key and a private key, asymmetric encryption is slower and is slightly expensive. Now, in symmetric encryption, name itself says there is a symmetry. That means I'm using only one key for encryption and decryption. And because I'm using one key, it is faster and it is less expensive. Confidentiality of the message is ensured by encrypting the message using a receiver's public key. Now, if in case you wanted to ensure the confidentiality of the matter, which is not being ensured or verified by the digital signature, then you can encrypt the message which you are sharing using the receiver's public key, whosoever is going to receive it. Authentication and integrity of the message is ensured by creating the hash of the message, also known as message digest. Do remember, hash as well as the message digest, they are both the same thing. And encrypting it using the sender's private key. Now, this is slightly technical, what I am talking about, that is encryption and decryption. One of the best way is that you study refer to the study material, and then you will be able to understand it more clearly. But for your understanding, I'll be repeating what I have said here with the help of a diagram. Let's see. Suppose you are signing a document or a data, document basically using digital signatures. So you are generating a hash using hash algorithm. Look at it, the hash value has been generated. Now this hash value is being generated, the hash value is encrypted using a private key. Now, when I have done this, I have digitally signed the document which I am sharing. Now this document, digitally signed document, travels across the network, and digitally signed document with the hash algorithm is now at the receiver's end. What receiver does it is decrypt it using the public key, because I have used it private key. So he or she has to use the public key. So when you are doing this, you find that the original hash which I have sent and the hash at the receiving end is generated. Both the hash values are compared. If they are the same, this means that the integrity of the document transferred across the network has been ensured. Means that during this transfer, during this transmission of this document across the network, nobody has changed the value. Had that been, suppose if someone has changed the value in between the transmission, then what happens? My hash value which I have encrypted and the hash value now that is generated at the receiver end will be different. That means this hash value and this hash value will not tally. This gives you a clear idea up to the receiver that, okay, fair enough, the message is not the original message which is being sent. I repeat once again. This time I'll repeat it in Hindi. Suppose if I, as a person, as a user, wanted to share a document across the network or send a document across the network, मैं हैश एल्गोरिथम का इस्तेमाल करूंगा. हैश एल्गोरिथम क्या होता है? It's a way of generating a string of fixed length. मैं इस hash value को जो generate होगी, because it is very sensitive to the content of the document which I am sharing. So ये अगर कोई भी content जो मैंने generate करा है content, उसमें अगर कोई भी फेरबदल करेगा, तो you will find that the value of the hash will change, right? So this hash, I will encrypt it using my private key, and then I will this is the way मैंने अपने document को digitally sign कर दिया. This document which is digitally signed will be sent across the network. जब ये receiving end पर आएगा, तो जो receive करेगा, जिसके लिए ये document है, उसे इस document को decrypt करना पड़ेगा using the public key. Now what happens when the decryption happens? तो दो चीजें होंगी. एक hash algorithm जो मैंने hash message digest भेजा था वो होगा, एक डिक्रिप्शन के वक्त फिर यहां जनरेट होगा. अगर ये दोनों वैल्यू हैश की सेम है, इसका मतलब डॉक्यूमेंट जो आया है वो ओरिजिनल कंटेंट है, इसमें कोई मैनिपुलेशन नहीं हुआ है. But if somebody has manipulated again in between, you will find that the hash value will differ. That's the purpose of digital signature. Again, I repeat it. डिजिटल सिग्नेचर इंटेग्रिटी एंड कॉन्फिडेंशियलिटी में फर्क करता है. कॉन्फिडेंशियलिटी का मतलब है किसी ने इस डॉक्यूमेंट को देखा नहीं. डिजिटल सिग्नेचर ये कभी भी नहीं कहता कि और ensures that the confidentiality is maintained. If you wanted to maintain the confidentiality, so then encrypt the message which you are using sending using the public key of the receiver. Confidentiality of the message is ensured by encrypting the message using the receiver's public key. जैसा मैंने अभी आपको बताया. Authentication and integrity of the message is ensured by creating the hash value, also known as message digest. I again am repeating it so that you remember message digest, and encrypting it using the sender's private key. For ensuring confidentiality, authentication, and integrity of the message, encrypt hash of the message using sender's private key. Now, this is again a value which I've taken from the question. This ensures authentication, non-repudiation, and integrity. So, agar hum dekhen, so if you carefully look into it, digital signature provides measures for authentication, which is non-repudiation and integrity, but it doesn't provide any means for ensuring the confidentiality. And if you wanted to confidentiality of the message to be maintained, then encrypt the message using receiver's public key. This will also ensure the confidentiality. So now to sum up over here at this point of time, when I'm sending a document using digital signature, digital signature serves the purpose of verifying and ensuring the documents integrity and non-repudiation and authenticity, but it will not ensure the confidentiality. If I wanted that this confidentiality is also included, then I need to encrypt the message which I am sending using the receiver's public key. This will ensure the confidentiality. That's all about the digital signature. We now move on to the biometrics. Now, again, this is a very, very important aspect. Now, biometric refers to the use of attributes such of human characteristics for identification and authentication. Now, biometric verification used based on unique identification of individual. You must have seen Mission Impossible 2, 3, where retina scan, fingerprints and saliva and DNA. There's so many biological features are there of individual which can be used for authenticating or verifying the individual's identity. Now, biometric solutions, when we are talking about, we need to talk about the accuracy measures because it's a machine which is reading it. Sometimes you find that when you're pressing your biometric fingerprints, if you're to access the particular room, it says access denied, right? And sometimes it happens that that a person who is not authorized and he tries and he gets the access to it. So these are the certain flaws of the system which we'll be talking about. So the first one says false acceptance rate, as known as FAR, that is access given to unauthorized person, jaisa abhi maine aapse kaha. And the second is false rejection rate, that is FRR, that is access rejected to authorized person. Now, see, the point is, what happens is that when you're going for a biometric, you have to register yourself with your biometric feature. For example, if I'm talking about fingerprints, so I need to register my impressions of my fingers onto this scan onto the machine, and then it gets registered. Now, later on, when I again try to enter the system, I put my finger and then this scan is matched with my earlier record. So if it is matched, I'm given the permission. If it doesn't match, I'm not given the permission. Now, the problem is these type of biometrics or biological features may change over a period of time. So like say, for instance, if I'm using voice for entering the room, right? Voice recognition. So it may happen that I'm suffering from a cold, my voice will not match, obviously. So I will not be given the access to it. So it's a case of false rejection rate, that is FRR, that access is denied to a person who's authorized to having access to it. Similarly, you may find a person who was not having a cold or something. His voice got matched with my voice, and he was not authorized, but he got access to it. That is a false acceptance rate. So these are the three important aspects I'll be talking about, which plays an important role when you are talking about the biometrics. And next is the cross error rate, also known as CER, or equal error rate. That is rate at which false acceptance rate is equal to false rejection rate. That means suppose if I'm pressing 10 times, I'm not being authorized, and 10 times I'm giving I'm authorized. So that is, it's a cross error rate. I'll be explaining it all these later. Both FAR and FRR are inversely proportional to each other. What I'm trying to say is the false acceptance rate and false rejection rate are inversely proportional. That means if access given to unauthorized person increases, then the access rejected to authorized person decreases. If access given to unauthorized person is very low, then access rejected to authorized person is very high. So you need to understand that when I say inversely proportional means if FAR rate is very high, you will find FRR is very low. And if FRR is very high, you will find FAR to be very low. So when FAR decreases, FRR increases. Similarly, when FRR decreases, FAR increases, and vice versa. Now look at it again, I'll explain it. Now, false acceptance rate, that means unauthorized people are getting permission to get into the system, or they are being recognized. Unauthorized persons are recognized, which means the false acceptance rate of a system, biometric system, is very high. If it is high, then what does it mean? That access rejected to authorized person will definitely be low because system is malfunctioning. On the other hand, if access given to the unauthorized person is very low, that is the false acceptance rate is very, very low. That means system is working very perfectly. As a result, you will never find any, very few cases will be there when you are rejecting an authorized person. It's as simple as it is. Point where both false acceptance rejection and false rejection rate are equal is known as cross error or equal error rate, EER. The most important performance indicator for biometrics is false acceptance rate, that is access given to the unauthorized person. This is very alarming because so many, for example, like if you're working in a bank, right, where thousands of employees are there, and for the regional office, the head office, where everyone is using the biometrics and for accessing the various departments of the bank. And if the false acceptance rate goes up, that means in a way what happens that unauthorized people are getting access to particular certain privileges, then it is very alarming because this indicates the performance or malfunctioning of the biometric system. So most important overall quantitative performance indicator for a biometric system is CER or EER, that is the rate at which FAR is equal to FRR. So this is an important point, that the quantitative performance indicator, if you wanted to check, then you have to check for CER. Similar, now we'll talk about, again, now it is seen that the retina scan, if you're talking about, you're putting your eyes for scanning the retina, has the highest reliability and the lowest false acceptance rate among the current biometrics method. Now, you will find that because retinas, when you are scanning a retina, you will find that unless and until you're suffering from diabetes or some other ailment, retina scan usually do not have this type of a system where you are being rejected. A genuine person is rejected. So you find that FAR is very low. So if false acceptance rate is, you will find that it is very, very less, which is the system is working very, very fine because all the authorized persons are getting recognized by the system. Now we'll talk about the intrusion detection system and the intrusion prevention system. Now, intrusion itself means some unauthorized person getting access to the particular facility or a particular system. Now, intrusion detection system is a device or a software application that monitors the network-based intrusion detection system or monitors a system that is host-based intrusion detection system for intrusive activities. Now, the intrusion detective system as itself is, when I'm talking about, या तो ये network level पर हो सकता है या एक system level पर, host level पर हो सकता है. दोनों level पर इनका main job of this intrusion detection system is to find out any unwanted and unwarranted activities taking place either at the network level or at the host level. Intrusion detection system is not a substitute for a firewall, but it complements the function of a firewall. And it's important. I have in my earlier, in my second lecture, I have talked about the types of firewall. Now, firewall these are basically the software as well as the hardware which are implemented in such a way that any person who wanted to enter into the network or to the system has to pass through that gateway. So if you are having intrusion detection system, these are the preventive measures. They will try to help or complement or facilitate the process or the functioning of firewall by giving an early warning system that certain areas are there where you need to pay more attention because certain intrusion activities have been detected either at the network level or at the host level. So if there are two, I have spoken about network-based intrusion detective system and the host-based intrusion detective system. Let's see the difference of the two. Network IDS monitors activities on identified network. Now, there are certain networks which are being identified, so they will keep on monitoring all the traffic on that particular network. And host-based IDS monitor activities on a particular system or a host. As I mentioned earlier also, host means we are talking about a single network, single system. But when you're talking about the network, then I'm talking about the traffic that is coming and going out from the system. Network-based ID is high false positive rate, that is high rate of wrong alarm. Now, what happens is that when you're talking about the network, it is very difficult to monitor that, or to understand the behavior of the traffic which is coming in. So most of the time you'll find that false alarms are generated. That means the person or the activity is not intrusive, but it is being considered intrusive, and then a false alarm is generated. But in the host-based intrusion detector system, you'll find, because it's a single machine, things are well defined. So the low false positive rate, there's low rate of wrong alarms. You will not find much wrong intrusive activity alarms in this case. Better for detecting attack from outside. Network is prone to get attack from the outside, because when I'm talking about network, then there is an internal network and which is connected to the external network using internet. So whenever my network is exposed externally, there are chances of intrusive activities. And for that reason, I use, normally we use network-based intrusive detective system. And this is better for detecting attack from inside. The host-based intrusive detective system is that somebody inside who's working within the organization might have a malicious intentions and may do this type of an activity. Now, types of intrusion detective systems, we have three types. Over here, it's a signature, statistics, and a neural network. Now, signature, this type of intrusion is identified on the basis of known type patterns of attack. Now, these types of patterns of intrusions are stored in the form of signature, and signature intrusion detection systems are also known as rule-based IDs. Now, I'll just give you an example how that will make you understand things very clearly. Now, what happens, like human body, you will find that whenever we fall sick or there is any viral infection, so what happened is that our body, our immune system maintains the signature of all the types of diseases that we have faced during the lifetime. So whenever we are getting an attack or a viral or any fever, then the signature stamp or the attributes of that viral infections are being matched with the signature already stored in our human immune system. And accordingly, the defense mechanism gets activated. That what type of antibodies have to be created in the body to fight with this type of intrusion. Similarly, what happens is that it says that we are trying to identify pattern types, and based on that, we maintain a log of what you call it as different type of signatures, which we have all. For example, जैसे आप अपने virus system को देखते हो, scanning for the virus means what? Your any type of security system is what? It's trying to identify the existing signatures of the viruses with the signatures of the viruses that are new and which are incoming. So this is the reason that people say that आप अपने security system और virus protection system को आपको बहुत update रखना चाहिए. Update रखने का मतलब it doesn't do anything. It keeps on adding new signatures of the viruses which are being detected to the library. So next time when any intrusion activity happens, that type or pattern of intrusion activity is checked with the database of the signature, and based on the matching of the pattern or the type with this existing signature, the defensive actions are being initiated. So that's the purpose of signature. Signature is, you can say, imprints also. Now, statistical IDS can determine the normal, known, and unexpected behavior of the system. Any activity failing outside the scope of normal behavior is flagged as intrusion. Now, statistical, I mean, obviously, you will say that what it means that then I know that under normal circumstances, this is the peak load test, this is the performance of the system, and this is how the system has to behave in a particular way. But if the system starts behaving abnormally, right, for no good reason, then the activity is falling outside the scope of the normal behavior. So in that case, what they do is that particular is being considered to be as a red flag. A red flag means it's a warning sign that there is some intrusion activity taking place. And that's how we talk about the statistical intrusion detective system. So what happens is that whenever a system is being created, there are normal behavioral patterns which are identified. Like if you're booting a system, it should take, say, let's say for instance 8 seconds. If the system is taking 40 seconds, that means the system will generate a red flag warning you that please make sure that there might be an intrusion activity. So again, I'm repeating it, intrusion detective systems are preventive. They will not control, but they will give you a alarm sort of a feeling that, okay, there is something wrong with the system, please go and check it. A neural network, these are similar to statistical IDs with added functionality of self-learning. Now again, heuristics you might have heard. Now, intrusion detector systems, they monitor the general behavior pattern of system activities and accordingly create and update the database. Now let's take an example. All of you must have worked in MS Word, right? So what happens is that when you create a new document and you look for a particular template, and the way you type and the way you everything, this MS Word after a couple of encounters will learn about my behavioral aspect of using the word. That is the self-learning. And then the system, MS Word will get customized automatically according to my preferences and the needs, right? What a neural network in intrusion detective system does, it says that these are again, very similar to statistical one. But here they, instead of raising the red flag and telling that the behavior is not normal, they say that, okay, if the behavior is not normal, then what can I do and what can I learn from this abnormal behavior to make this behavior normal? So these IDS intrusion detective system, which are neural network, they monitor the behavior, they monitor the pattern, and they learn from that pattern and accordingly update the status as to what should be done next. So again, these intrusion detective system, always remember, these are preventive control measures. They will not do anything. They will only raise a red flag or alarm or warn the system user. Only neural network creates its own database and is more effective in detecting the frauds. Now, if you, for example, if a particular system is being authorized, to accept only digits, or say, let's say, for instance, certain set of numbers, alphanumeric numbers, and if you are repeatedly doing this wrong mistakes, then what happens? It says that, this is not acceptable. I'll just give you a small example of, let's say, for instance, neural networks. You must have used your ATM cards. This is not a correct example, but this will make you understand what it does. You type a wrong PIN. Second time you do the wrong PIN. Third time it says the system is locked. What that means, this particular neural network type of system has understood that the user is trying to forcibly access this particular card without using the genuine and the correct PIN, that is identification number. So what it does, it says the system has learned that if you are crossing three times, or maybe you are touching 3 times, then it will lock it. Similarly goes with the password. When the systems keep on typing the wrong password and say that the system has locked you for some time, and for unlocking yourself, get in touch with the administrator. This is the job of neural network. Now, here you will find that this neural network is, in a certain way, is very, very effective in detecting the frauds. It is taking action only to a limited extent. It is, again, not doing anything. See, it is just preventing. It is detecting and it is trying to hold and prevent it, right? So statistical ID generates most false positive. There is a false alarm. This is a question which was asked. So please be very careful about it. False alarms means when you are putting statistical ID, then you are statistical ID in the sense you are trying to learn the behavior, normal behavior and the abnormal behavior. So this may generate a lot of false alarms and the false positives, what we call it. That is, it may not be an intrusion, but it will give an impression that yes, it's an intrusion. Now, limitation of intrusion detection system. Now, let's look at what are the limitations. IDS will not be able to detect application level vulnerabilities. Now, again, the first module I have talked about vulnerabilities and threats. Now, let's put it this way. Threats are always external, coming from the external environment, and vulnerabilities are all internal. So what I'm trying to say is that if your system is having internally some weaknesses or some loopholes or some openness where the intruders can attack or enter into your system, then IDS will not be able to do of any help. In that case, firewalls are very, very helpful. So IDS will not detect any application level vulnerabilities, what I'm trying to say. System level is definitely taken care by the operating system, but in your application, if you have any vulnerabilities, so then you should not expect that IDS starts working at the application level. No, it won't. So these are the few limitations. IDS will not be able to detect backdoors into the application. So normally when you are using applications, pirated applications, for example, if you have a pirated version of MS Office, so what happened is that these applications which are not genuine or not licensed, they have certain backdoors or certain openings or certain loopholes, if you put it this way, through which intruders can access your system. So this is the reason it is always advised that we should use the licensed software. So both the IDS, if you look into it, we'll put it this way, that intrusion detection system will not be any help in detecting anything if there is some problem with your applications, right? IDS will not be able to detect encrypted traffic. Now, again, I said, intrusion detection system is a preventive control measure. It will not do anything, but it will generate an alarm sort of a thing. And that is of more help to the system administrator, for taking necessary action. Now, how do we place the intrusion detection system? It's again, let's see. The network-based intrusion detection system is placed between internet and the firewall. Look at the diagram. You will have internet outside network, then intrusion detection system, then you have firewall, and then you have internal network. Now, this is one type of a placement where you are using intrusion detection system also in firewall, which means IDS kya karega? It will complement the working or functioning of firewall. Now, IDS will do what? It will make firewall more effective, because IDS will generate alarms, red flag, which will be stopped by the firewall before the traffic moves into your internal network. Now, placement of intrusion detection system, another type can be that you have internet, then you have a firewall, you get directly into the firewall. Traffic which comes after or from the firewall again goes into the intrusion detection system before it goes into the internal network. Now, this again, it's a corporate and a policy decision that how you put your IDS. Ideally, internet, IDS, and firewall and internal network works the best. Now, intrusion prevention system, that is known as IPS, they not only detect the attack, but also prevent the intended victim from being affected by the attempt. Now, let's put it this way. I've been talking about, IDS is preventive control measure, and intrusion prevention system is there'll be a corrective action. Look at these two images which I'm showing. This is the one officer which is giving an information that, I see some intruding activities at the door. The IPS, that is intrusion prevention system, it says, okay, come on, I have a gun and I'll fire if you move ahead. So this is the difference between the two. So then we have a single sign-on. Again, single sign-on is a user authentication service that permits user to use one set of login credential, that is name and a password, for accessing multiple applications. You've often seen that if you're working in an environment, if you get access to, if you log into the MS Office, then you'll find that Word, you're working on a Word, and you're working on PowerPoint, as well as you can work on all the applications of the MS Office. That's single sign-on. Similarly, if you log into the Google, then all the services and applications which are offered by the Google, you will allow you to log in with once log in with your credential, that is name and password, and this user authentication service of single sign-on gets activated. And all the platforms on which the Google, or all the services that Google offers, you are immediately logged on. Now, this is SSO, that is single sign-on. You must remember, this is the technique of user identification for using your only you use once your name and password for getting access or logging to the system. And what are the advantages? I'll read. Multiple passwords are not required because it becomes difficult to remember them. This encourages users to select a stronger password. Now, obviously, when I have to select lesser password, I'm very particular about it and I use a strong password. Improves administrator ability in managing user account, because now user accounts can be managed by the system administrator carefully, reduces administrative overhead, cost in resetting the password, and reduces time taken. Now, a disadvantage of single sign-on is SSO act as a single authentication point for multiple application, which constitutes a risk of single point failure. Now, right now I've said that you log in with your, as if single sign on, you are on with once you log in and you have access to the plethora of services under that particular domain. Now, imagine if you could not sign on with you forgot your single password, then in that case, you will also become a single point failure. That means you cannot access the services. Sorry. Now, single sign-on versus reduced sign-on RSO. Now, in a single sign-on, user has to log in just once for all the application. The name itself says. In reduced sign-on, user has to log in individually to each application using same user ID and password. So also keeps authentication frequency low. Now, there is another option which is given, is that a single sign-on says that I log in once and I'm accessing all the services offered. RSO, that is reduced sign-on, says that okay, fair enough, for different applications or within the particular group of applications, you may use the user ID and a password. Same can be used, but you have to log in separately. So this RSO keeps the authentication frequency low, because now it's saying that once you have logged on, so when you're logging into the next application with the same password and the user ID, it doesn't makes easy for you to do that. When we have a Kerberos, that is, it's an authentication service for validating services and user in a distributed computing environment. Kerberos is a third-party application for verifying the identity. It is an example of a single sign-on. In distributed computing environment, both user and server authenticate themselves. We'll be talking about this. Now, Kerberos is an authentication service. Now, these are all very technical. One question I have once encountered, they have asked about, which is related to single sign-on, and they have used this Kerberos theory. So they say that which of the following option offers the single sign-on facility, and if you find Kerberos, you will see that this is a third-party application. That is, it is not somebody else is developing the application for you, and third party is going to verify your identity, right? It's an example of a single sign-on. That means when I'm logging onto it, there is an application which is generated by the third party who is not known to me and to my application. And that party, application party, verifies my identity, and based on that, I am given the access to the system. So this Kerberos is an important section to do remember for your exams, that Kerberos is an authentication services for validating services and user in a distributed computing environment. A distributed computing environment, you can say that it's a client-server computing environment, and it is an example of a single sign-on. This only thing you should remember, right? So with this, I'm signing it off for today, and thank you for watching. And I'm hoping that those who have seen my videos will be able to clear this exam, and wish you all the very best. I regret that I took a lot of time in making these videos, but I assure you that I don't say that you should appear in the next exam again. But those who still couldn't make it for this time, next time you will have all the 6 module videos up and running along with my book, which will be published, which will be available in the market, right? So thank you very much, and I wish you all the very best for your future exams. Thank you.